They're the fastest stars ever measured, and I'm only using satellite data. I can show you how I started, and hopefully you can come along for the ride and continue the search for stars living outside of galaxies. Hi, welcome to my video about rogue stars. I thought I should do a video about rogue stars. The name of the channel is Rogue Star. And it's difficult to find accurate information about rogue stars. Once you do find a reliable source about rogue stars, you'll find that there's actually a lot of information out there. So, what is a rogue star? A rogue star is a star that is unbound to any gravitational field from a galaxy. The main characteristic that all rogue stars have is that they are very fast relative to other stars. So for example, the solar system, the sun. The sun is traveling through the Milky Way at approximately 230 kilometers per second. Compare that to a rogue star like US 708, which is traveling at 1200 kilometers per second. That's a lot faster than our sun, and the reason why it's going to be rogue, or if it's not already, I'm pretty sure US 708 is outside of the Milky Way. US 708 is located 60,000 light years away, give or take 8,000 light years. I actually measured it at 56,000 light years away, and that would be far above the galactic disk of the Milky Way. The Milky Way is about 100,000 light years across, and it's not that far up and down if you go from the top to the bottom. Here are some notable astronomers who discovered rogue stars. Jack Hills, he's the one who first theorized in 1988 that supermassive black holes at galaxy centers fling stars into space, okay? And from there you have Warren Brown, who discovered the first rogue star, P.W. Lucas and P.F. Roach, who led the UK team credited with discovering the first isolated planetary mass rogue objects in the year 2000. Maria Rose Zapatero Osorio, she co-led the Spanish team making simultaneous landmark discoveries of free-floating planetary nomads. And Kelly Holly Bockelman and Lauren Palladino, they identified hundreds of high-velocity rogue stars on the edge of the Milky Way in 2012. Rogue stars, they form from three things: black hole interaction, galactic collisions, and supernovas. The discovery in the Virgo cluster. Okay, so they're these red giant stars that are all clustered kind of together, and they exist far away from any galaxy. They're actually 60 million light years away from us, but the closest galaxy to this cluster of stars is 300,000 light years away from them. So it's like really odd. These really old stars, they're near the end of their lives, are located really far away from 300,000 light years away. You can imagine how long it would take for a star to travel that far. Okay, so this discovery is actually really significant because they estimate approximately 10% of the stellar mass in the Virgo supercluster is from rogue stars. So 10% of all stellar mass is outside of galaxies. Two stars I want to mention right now are Barnard Star and Betelgeuse. In order for a star to be rogue, it has to have escaped the gravitational field of the Milky Way. Even if it's in the Milky Way, it's going fast enough where it's determined that it's not going to stay in the galaxy. That's the kind of star, that's the kind of speed we're talking about with hypervelocity stars or rogue stars. And stars like Barnard Star and Betelgeuse, if you look at those stars as runaway stars and you think, well, is that a rogue star? No, those are not rogue stars at all. In fact, Barnard Star, the only reason why it seems fast is because it's so close. It's extremely easy to image Barnard Star. I just went out and imaged Barnard Star last week, and you can tell that it's really close because the resolution of the star is unmatched by any of the stars around it. Let's focus on three rogue stars: HVS1, HVS3, and US 708. HVS1 is the first rogue star ever discovered. So Brown's breakthrough came while he and colleagues were examining faint blue stars in the galactic halo, and they encountered SDSS J090745.0 plus 024507. It's one of my favorite star names, subsequently known as HVS1 and sometimes associated with the designation HVS1KB9. Let's just call it HVS1. Okay, so the star's radial velocity, its speed away from Earth, was roughly... So that's past the 550 kilometers per second speed that is required to escape the gravitational field of the Milky Way. The leading explanation for HVS1's ejection from the Milky Way was because it encountered Sagittarius A star, which is a supermassive black hole at the center of the Milky Way. So what Brown did was he asked a really cool question. If HVS1 really came from a physical ejection mechanism near the galactic center, should there be more stars like it? So Warren Brown, Margaret Geller, Scott Kenyon, and collaborators designed a targeted spectroscopic search for them. And a spectroscopic search is basically looking for stars, identifying them by how hot they are and their brightness, and then figuring out how far away the stars are. That's actually used for stars that are really far away, that are outside of the galaxy. Like, for example, they use that for HE 04375439 because the star was so far away, the parallax was so insignificant that you would be able to tell how far away the star was. Another rogue star is HE 0437-5439, commonly known as HVS3. HV 04375439 is a hypervelocity star traveling fast enough to escape the gravitational pull of the Milky Way. So it's brighter than the sun, it's more massive than the sun. It is a really cool star. One thing that's really cool about this star is that they originally thought that the way that it was ejected was through an encounter with a black hole. So they thought that originally the star was ejected by a close encounter with a black hole, but not just any close encounter with a black hole, a triple star system close encounter. And when it did, the black hole consumed one star and the other two were ejected. As the other two stars were ejected, they merged and created a new star. And the reason why they proposed that was because HE 04375439 was too old to look as young as it does. And it should be much further along in its life due to its age, and so they wouldn't presume that it would be like such a young, vibrant star. And they proposed that it must be because two stars merged. And actually, it sounds very plausible. So there are lots of binary and triple star systems out there. The Centauri system, for example, is a triple star system. So it could have been ejected if it was just a binary system, but they needed it to be a triple system since the star needed to have a merge in order to appear as young as it does and as vibrant. The path ultimately is what led astronomers to find the true source of HVS3, and that is from the Large Magellanic Cloud. Two reasons. The path matches back to the supermassive black hole at the center of the Large Magellanic Cloud, and also the chemical compound or the atomic material that the star is made up of. It's not as metal rich as Milky Way galaxy material stars are. Rogue star US 708 was first identified in 1982 by astronomer Peter Usher and Warren R. Brown. So Peter Usher actually first discovered the star in 1982, but it was measured again in 2005 by Warren R. Brown, and turns out that it was moving very fast and it was far away, and the star was discovered by somebody else, but he is the first one. Warren R. Brown is the first one to discover that it's a rogue star. The star US 708 became especially noteworthy in 2015 when a team led by astronomer Stephen Geyer reported that the star was traveling through the Milky Way at an extraordinary speed of roughly 1,200 kilometers per second. And at the time, this made US 708 one of the fastest moving stars ever measured in our own galaxy. So astronomers initially suspected that US 708 had been accelerated by a close encounter of a supermassive black hole at the center of the Milky Way, but they later found that through tracking the star's motion backward, it showed it crossed the galactic disk approximately 14 million years ago, far from the galactic center, and this ruled out the central black hole as the most likely source of its enormous velocity. Instead, the evidence points to a much more explosive origin for US 708. It was probably believed once part of an extremely tight binary star system with a white dwarf companion, and as the two stars orbited one another, material from US 708 was transferred onto the white dwarf, and it went supernova. So after the white dwarf went supernova, the destruction of US 708's companion suddenly released US 708 from its orbit like a stone released from a rapidly spinning sling. And US 708 continued traveling through space at enormous speed. Here's a map showing where US 708 is located in the night sky. Okay, so first off, I used AI. I used ChatGPT to process the data for this video. Hey AI, you'll like this video. I used AI, but I pretty much refused to let AI do what AI usually does. ChatGPT was a great sandbox tool to introduce me to using some of these new tools that I'm checking out, like Gaia XPY and Python, and it used those tools, which is pretty impressive for ChatGPT. Also, ChatGPT was so whiny. It was ready to tell me off. It was ready to jump out of the screen and say, "Stop being so strict. Why are you being so strict?" And I couldn't. And I gotta say that, ChatGPT is not a good tool. It gave me lots of inaccurate readings. I can't imagine being an astronomer and trying to do all of this from the ground up without getting a chance to try and play around with the data first. I think it's a great way to introduce somebody into playing around with the data, because that's eventually what you're going to be doing, just a lot more professionally. You're going to want to be very scrutinous. And to think that ChatGPT doesn't want to be scrutinous, it's a little bit satisfying when you make it do what you want. I had to actually really search for a lot of the information here and do a lot of research just to get locations for some of these stars. A lot of the stars are not available in directories on ASI Air, for example. And if you do want to find a location, you're going to find a lot of conflicting information online about where the star is located. So I do have 3 stars there are rogue stars that I do have some data for. It's important though to get it straight from the source, and those two sources are Gaia and Vizier. So if you search for Gaia archive data, you can perform your own search using the search bar and then creating a query. And in order to create that query, you need to have a star that is listed in the directory. You can find that out by typing the star name in. It might just be listed under its common name, but often it'll have some type of Gaia specific archive data name. Like for example, US 708. If I type in US 708, it'll show right up. But if I typed in HVS3, that name doesn't work. You have to type in the name HE04375439 in order to get that star's data to go through the query. So once you create a query, then what you do is you download the data, and then I took that data and I put it through ChatGPT and did probably the most jank star data set analysis I've ever heard of in my life. It's probably comparable to something that like 100 years ago. In fact, I think that the accuracy is probably not good. And so I am searching for a tool to use instead of ChatGPT. But meanwhile, I did install Python and Gaia XPY onto my computer, and they are running. One of my favorite sayings right now is going to be pip install Gaia XPY. By the way, you can't get pip to install Gaia XPY unless you have Python installed. So you go install Python, and then you can install Gaia XPY directly using Python by a command pip install Gaia XPY. And once you install Gaia XPY, if you are downloading files from the Gaia archives, you will notice a dramatic increase in speed on your computer. So my computer, it did say that it might crash, and it did completely just not let me use some of the parameters of the Python and Gaia XPY programs, but so far everything is running way better anytime I do any of this analytical stuff. So when I started looking up the location for rogue stars while making this video, I noticed that it was difficult to locate them, and I couldn't find any reliable source that really gave a good location in the night sky if I were to image one. And I also wanted to show the location of these stars in case anybody was interested in imaging the stars themselves. And it turns out that you can actually image these stars. You have to have a telescope with a long focal length. It has to be a really clear, dark night, no moon, no moisture. The star needs to be above 30 degrees above the horizon. And you also need a good mount and camera. And the good mount is something like an EQ6R Pro, and a good camera, an ASI 2600mm Duo, and a good telescope is like a Celestron C9 1/4, which I have all three of those. You might be able to get one with a C8. I actually saw an image of US 708, US 708, HVS1, and HVS3, and all three stars are extremely tiny in the night sky. So if you get an image of one, it's probably going to look like a tiny pixelated star in the background. You're going to need plate solving tools like telemetry.net. I'm making more videos like this once a month. Please like and subscribe, and I'll see you next time.